Assalamu alaikum. Hi everyone. In this video, I would like to share with you how do we solve a system of linear equation using the Gauss-Seidel method with Matlab Programming. As we know, there are two main approaches in solving the system of linear equations. The first is known as the direct methods, and the second is known as the iterative methods. So the Gauss-Seidel method, which is similar to the Jacobi method, is categorized under the iterative methods, which means we need to have some iteration formulas such that the new value depends on the previous value. Alright, to demonstrate the Gauss-Seidel computation, let's consider this circuit on your left hand side. Our task is computing the values of the nodal voltages V1, V2 and V3. Please not to be confused between this small v1 and small v2 with this capital V1 and capital V2, because this capital V1 and V2 are constants. They are the voltage source. Alright, suppose that from the nodal analysis we managed to obtain the circuit equations in matrix form, where this A times V equals to B, in which A is a 3 by 3 matrix, B is a 3 by 1 matrix, and small v is the vector of the nodal voltages consisting V1, V2 and V3. Alright, so we can begin with the Matlab programming. I normally begin my end file with clear and CLC for the purpose of clearing the, what do we call this, workspace, and also clearing the command window. And then suppose that the values of R1 until R5 are given like this. R1 is 2.2 kilo ohm, R2 10 kilo ohm, and so on. And then the value of the voltage source V1 is 12 volts, V2 is 3.3 volts, and I1 is 2 milliampere. Alright, so from the nodal analysis we managed to get this equation. That is, let's place some comment in here. A times V equals to B. Now we can find the value of V by using the built-in inversion function, because Matlab has already the matrix inverse function. So let's write V underscore ML to indicate the value of nodal voltage provided by Matlab using the built-in inverse matrix function. So V equals to inverse A times B. So if I run this program up to this point, I will get, and we have to save this first, Gauss-Seidel, for example, nodal. So by using this INV function, we get the value of the nodal voltage V1 equals to 12.5683, V2 20.2562538, and V3 equals to 9.0476 volts. Okay, now we want to prove that by using the Gauss-Seidel algorithm we managed to get the similar answer. Alright, so what is the basic Gauss-Seidel formula for this problem? In fact, it can be written as V1 equals to 1 over the elements of A11 times V1 minus A12 times V2 minus A13 times V3. So this is the first line of the Gauss-Seidel method. Since we have V1, V2 and V3, we can edit the first line. So this is V2, should be 1 over A22 B2 minus, in here it should be A21 V1 minus A23 V3. And the last equation of the Gauss-Seidel is V3 equals to 1 over A33 B3 minus A31 times V1 minus A32 times V2. Okay, so this is the basic formula, basic Gauss-Seidel formula for that circuit. Okay, from this point, in fact, I can solve this set of equations directly using the Gauss-Seidel by using the for loop, for example. But first I have to initialize the value of the nodal voltage. I can write V equals to 0s 3, 1. Since my V consists of V1, V2 and V3, I want to assign all of them equals to 0, so I write V equals to 0s 3, 1. If I highlight this line and evaluate that, I get this, V equals to 0, 0, 0. And then from here I can create, let's say, by using the for loop from k equals to 1 until 50, and I place these three equations in the for loop, and I write and. If I run my code right away from here, I get the value of V is this, 12 point this and this is V1, V2 equals to 20.25 2538 and V3 equals to 9.0476, which is exactly equal to the value given by Matlab. Okay, by the way, how do I know that how many iterations that is required? Is it necessarily 50 or maybe less, or maybe just a few? So a more practical way is by using the stopping criteria. For example, I can write the error, let's say E equals to V minus V old, in which V old equals to V. Okay, by the way, since V consists of multiple numbers, V is a vector, so I have to put a norm for the stopping criteria. And then I can place if EE less or equals the tolerance. For example, I can put epsilon, in which I can specify my epsilon, for example, equals to 0.0001, and then I put this. If EE less or equals the epsilon, break and end. Alright, so let's run until this point and see what do we have. Okay, now from the workspace I know that I get the value of v equals to this in actually up to k equals to 12. So my iteration actually stopped from 1 until 12. And then how can I know the results of my iterations? Let's say from k equals to 1 until k equals to 12. How does the value of v converge? So it's better to print the value of each iteration on the command window. So the way is by using the fprintf. Let's say here we write fprintf we wish to have the value of k and then v1 and then v2 and v3. So we have to use this special character, place this inverted comma. Since k is decimal number, I can write 2d, means that the space I give two digits for k, and then let's say 6 digit for v1 with 4 decimal places. F is corresponds to floating number, and even for v2 and v3 we specify with the same length and decimal places. 6.4 f. Let's close this and run until this point, and let's see what do we get. I forgot to place the enter. So enter in MATLAB coding is \n. So this is the result. So where is the initial value? So maybe we have to copy this before the for loop and paste it before the for loop, so that we manage to get v1, v2, sorry, this should be v2 and v2. So 0. Okay, so from the initial value, this is actually k, v1, v2 and v3. I think it's better to label this table. So let's label the table with k v1. I prefer to write in this manner, v_1 k, and then v_2 k and v_3 k. So we need to change in here because now all these symbols are considered as string. So put s, so 10s, the length of the character is 10, 10s, 10s. So that when we run this, we manage to get the header. So why does it looks like this? Because kv1 maybe we need longer length, 10 perhaps, 10, 10 and 10, and so this is not that important, but just for the sake of presenting our data nicely. Okay, now we have this. So this is the results of the iteration, in which it shows how V1, V2 and V3 evolves from its initial values to the final value. Instead of using the for loop, we can also manage to achieve this by using the while loop. For example, we can replace this for with while 1, meaning that this loop will repeat forever until it satisfies this condition. By the way, since we have removed the k equals to 1 until that number, we have to write k in here begin with 0, and then before the end of the while loop we put k equals to k plus 1. So if we run up to this line, we can get the similar answer. The thing is, if we use while loop, we have to be careful, because why if this condition will never satisfy it? So perhaps we have to put another criteria. For example, apart from epsilon, we put one more stopping criteria, which is the maximum number of iteration. Let's name it as max iter. Let's put it as 50. So either this condition satisfied, or in Matlab is this, or k equals or k greater or equals to max iteration. So no matter whether this the algorithm converge or not, okay, it will stop at maximum iteration. But if this satisfied, it will stop in any points of iteration. So we rerun our code and we get the same solution, the same results. Okay, next, what can we do to improve our program? If in this case the size of equation is only 3, in which our matrix A is 3 by 3 matrix. What if the size of the problem is larger than 3, maybe 5, 6, maybe 10? So can we write this in a more systematic way? As an example, if we inspect these 3 equations, we notice some pattern. If I put some spaces in here, for example, I press spacebar up to here, and then here, and then like this, maybe this, like this. So if we inspect this line, we notice that there is some pattern. The only difference is this is 0, 0 and 0. By the way, this is in fact equals to the first row of matrix A, you know, B1 minus the first row of matrix A times V. In the only exception is the element of A11 is set to 0. So can we do something in here? For example, if I introduce one matrix, let's say somewhere here, for example, C equals to A. First, I want a matrix C exactly equals to A, then I want to make the diagonal of C become 0. So how to do that is by using the for loop. Let's say from I equals to 1 until 3. Okay, Ci equals to 0. Then end. Okay, if I run this part of code, I get a matrix C. If I type C in the command window and hit enter, I get matrix C is almost the same with matrix A, but the only difference is the diagonal has been set to 0. Okay, so meaning that if I can change this line with B1 minus C 1 colon, meaning that the first row of matrix C times V. That's all that I need. And similarly in here, and here. So for the second equation, this is B2 minus the second row of matrix C times V. And for the last equation, B3 minus the third row of matrix C times V. Let's run this equation, this code, because we have done some modifications and we hope nothing changed. Yes, but we got the more compact form of code. Secondly, this has some patterns between this set of equation 1 2 3 1 2 3 1 2 3 1 2 3. So maybe it's better to use another for loop. Inside this while loop, we put a for loop for, let's say again, I equals to 1 until 3. Vi equals to 1 over A I times Bi minus Ci colon, meaning that the ith row of matrix C times V, and end. And we can remove or comment these 3 lines. And let's rerun. Okay, this no need to write the Vi in here. Again, V equals to, I forget the close bracket, and another mistake is, yes, this must be I. Okay, alright, so yeah, this would be Vi equals to 1 over AI times Bi minus the first row, the ith row times V. Next, what other improvement that can be made? Maybe we can make this code more general. For example, let's take one variable, let's say mn equals to size of matrix A. When I write this, when I evaluate this, I get m equals to 3, n equals to 3. Actually, m equals to n because this is a square matrix. So to make this code more general, instead of writing 3, 3, and 3 here, because maybe in other problem the size of the matrix more than 3, so we can change this to n, small n. here, in here. By the way, for the fprintf, we have to modify it manually. So if I run this, I still get the same results. Okay. By the way, there is an awkward result in here because K00 appeared twice. So perhaps we need to move this line, you know, because first K 0 and then it's still 0. So maybe we have to move K equals to K plus 1 in here. So let's rerun, and you see now it's become more logical. Before I end this video, it is worth noting that to guarantee the convergence of the Gauss-Seidel solutions, we have to ensure that the matrix A is diagonally dominant. So maybe you can improve this code by adding a few lines that checks whether A is diagonally dominant or not. Diagonal dominance is not compulsory, but it is sufficient condition to ensure that our Gauss-Seidel iteration converge. So that's all for now. Thanks for watching.